Alright, so this is going to be the derivation of the law of cosines. And I wanted to show you the picture that I'm going to use before I start the derivation. So you'll see here that I've taken a triangle and I've divided it up into two right triangles by dropping an altitude, just like I did with the law of sines derivation. But this time, instead of ignoring the b and the angle b and the side opposite b, I'm actually going to treat them as they are. Side b, by dropping this altitude, gets divided up into two pieces, one of which we'll call of a length of x. That'll be in this triangle. And in the other triangle, this length would then be the entire side little b minus this x, and that would be this length. So for this derivation, this is the picture we're going to be using. Now, the way this works, alright, so if you look at these two right triangles here, the one on the left has legs of x and h and a hypotenuse of a. So I'm using the Pythagorean theorem here to show that h squared plus x squared equals a squared. And if you look at the right-hand right triangle, you see that this leg squared plus this leg squared is c. So I've written that here. H squared plus quantity b minus x squared equals c squared. What I'm going to do is, you see each of these things has an h squared in it, so I'm going to get each of these equations with h squared on a side by itself. And that'll allow me to set those two equations equal to each other because they both equal to h squared. So that looks like this. Now, I have something here that if I were to FOIL that left side out, I feel like I would have some stuff that's similar. So I did actually FOIL this out here. That gives me this. And now I'm going to take that negative and I'm going to distribute it to everything. So that would give me this. So now on both sides of the equation, I have a negative x squared. So I'm going to add x squared to both sides. And that leaves me with this. Now, I have this relationship that has stuff from the original triangle here, except that x. That x wasn't part of my original triangle that was there before I dropped the altitude. So I'm going to look for ways of getting rid of that x and replacing it with stuff that I had in the original triangle. So if I look at where x is right here. It's in a right triangle with, from the original triangle, little a and capital C. So if I think about capital C being an angle in a right triangle, little x is the adjacent leg, and a is the hypotenuse. So that means that the cosine of big C is x over a. That allows me to get x by itself by multiplying both sides by little a, and that gives me an expression for x in terms of things I had in the original triangle. So I'm going to take this equation that I got right here and replace the x with this stuff, and that looks like this. Now, this is the law of cosines, but it's not an easily memorizable form. So to make it more easily memorizable, I'm going to move things around, and you'll see what I do here. I'm going to take everything except for the c squared and move it to the other side. Now the reason for that is because the one identifiable feature in the law of cosines that sort of centers the whole process is which angle you're using. So if you look in my cosine, the c is the angle I'm using here. So I'd like the side opposite that c to be on the opposite side of the equation. So if you do that, you get this. Now if you cover over the negative 2ab cosine c, you see you get c squared equals a squared plus b squared, which is the Pythagorean theorem. That makes this a lot easier to memorize, but it also tells you, you're going to learn this later, that the Pythagorean theorem is actually a special case of the law of cosines. Now, one of the things you'll often see textbooks do is they'll write the law of cosines in 3 different forms that look like this. This is stupid. These are all the same rule. If you look at the angles that are in the cosines, C, A, B, on the opposite side of the rule, it's the same letter. It's just the opposite side of the angle that's in the cosine, but it's the exact same rule over and over again. So if you just remember that when you're using the law of cosines, you base it off the angle that you're working with, and then the side opposite that goes on the opposite side of the equation, and you fill in all the rest of the stuff in the formula with the other two sides, you'll be good to go. And that's the derivation of the law of cosines.